This lesson is all about the equation of a circle. Here is the simplest version. If you have a circle centered at the origin, the equation of that circle will be x squared plus y squared equals r squared, where r here is the radius of the circle. So for example, you can easily see that the radius of this circle is 6. So that would make the equation of this circle x squared plus y squared is equal to 6 squared, or x squared plus y squared is equal to 36. Okay, so that's how it works when the circle is centered at the origin 0, 0. But what about when it's not at the origin? Well, then we have to use a more generalized form for the equation of a circle. By the way, this is called standard form when it's written like this. And we have, instead of just having x squared and y squared, we have x minus h and y minus k. Now, in this form, the center of the circle is h comma k. So if you see the number here and the number here, that's going to tell you the center of the circle. When you do formulas in mathematics, a negative sign right here basically tells you to take the opposite sign of whatever you see. So this minus sign and this minus sign tell us that we'll do the opposite of what we see here and here, and that will give us the center. The radius is still r, of course. Okay, so for example, looking at the circle that I have drawn, the center is here at 4, -2. And the radius is still 6. Alright, so the equation of this circle would be x minus 4 squared. Alright, there's the 4. Notice it's a positive 4, and so we have the minus. These are sort of opposites. And then we'll have y plus 2 squared. Alright, the y value is -2, so again you basically do the opposite. And we're still going to have 36 here. Since the radius is 6, we're doing 6 squared, and there's 36. So that is how you set up the equation of a circle if it's not at the center. Notice that this equation still works for when it's at the center. It's just that the center would be 0, 0. So if you did have a circle that was at the origin, that would just become x minus 0 squared, y minus 0 squared. Okay, and with the zeros, it just turns right back into x squared plus y squared equals 36, which is what I showed you the first time. So it is very useful to have the equation of the circle written in standard form, because at a glance you can see the center and the radius. Very useful. But sometimes we get the equation in another form and we have to convert it to this form. Alright, this form of an equation of a circle is called general form. And general form is less useful. So sometimes we arrive at an equation in general form and it doesn't have our nice parentheses in it. Okay, so at a glance there's no way to easily tell what's the center and what's the radius. And here this question is asking us, what is the radius? I don't know. I have no idea what the radius is right now. So what we have to do is change it. We have to transform it from general form into standard form, which is this one. Okay, now in order to convert from general form to standard form, we have to have a lesson on something called completing the square. So we'll come back to this problem in 3 minutes. I have to give you a brief lesson on completing the square. Alright, look at this quick example of how we could solve this by completing the square. First of all, this number right here has to be a very special number, which we'll get to in a moment. And for right now, just take my word for it, this is not the right number. So we have to move this number out of the way by subtracting it from both sides. Okay, so now I'm just going to recopy, and that number is now gone. But I'm going to leave a gap here. I'm going to leave a space. So I have x squared minus 10x, leave a space, is equal to negative 3. Now my next step is where I am completing the square. I'm picking just the right number to make this into something called a perfect square trinomial. We'll worry about that later. The way you pick the number is look at the middle, take half of the middle number, and then square it. So what is half of this? Depending on how you look at it, you might be saying 5 or negative 5. Well, it doesn't matter. Either way, if you take half of this and you get 5 or negative 5, if you square it, what do you get? You get 25. That's the number that needs to go right here. Either way, you get positive 25. Now, as soon as I put in this 25, I've changed the equation. All right, before I put in the 25, this is a valid equation. The left side equals the right side. By putting a 25 over here, I've thrown everything out of balance. Okay, so I have to keep the balance by adding 25 to both sides. Now they're still equal. That's very important. A lot of students will add in the 25 only on the left and forget the right. That's the most common mistake. Now, here's why we did that. If we go and factor this, and so you have to remember something about factoring from your previous classes. If I factor this, x squared, that must be x times x. 25 would come from doing 5 times 5. Okay, and depending on how you learn this, you're going to approach this differently, but the way I learned it was the inner and the outer together have to give you the middle. So inner, I have 5x. Outer, I have 5x. I need to make negative 10 out of it. So that means they both have to be negative 5. So negative 5 and negative 5. And it works because negative 5 times negative 5 is positive 25. So there we factored it. Okay, if you need a completely separate lesson on factoring, let me know. So we've taken this and we've factored it as x minus 5 times x minus 5. Meanwhile, on the right hand side, negative 3 plus 25, that's 22. Okay, now the benefit of what we just did, by picking the 25 so carefully, we have guaranteed that this will factor as the same thing twice. That's not a coincidence. Because it's the same thing twice, x minus 5 times x minus 5, we can write that as x minus 5 squared. So that's what we do. Now, in previous lessons, we've learned how to unsquare things. We unsquare things by taking the square root of both sides. Don't forget that the solution could be positive or negative, so we'll do plus or minus. So this unsquares the x minus 5. That leaves us with x minus 5 is equal to plus or minus radical 22. To solve this, we'll finish up by getting x by itself by adding 5 to both sides. Okay, and I'm just going to put the 5 in the very front, and we'll get our final answer that x equals 5 plus or minus radical 22. Okay, that would be the final answer. Alright, that was just a review of something called completing the square. So what does that have to do with finding the radius of a circle whose equation is given to us in general form? Well, our first step is going to be to take general form, and we have to convert this to standard form. So let's see. So step 1, convert to standard form. Okay, that's very messy, but you can read it. the way we are going to convert to standard form is by completing the square. We're actually going to have to complete the square twice. In fact, I'm going to have to erase. I need lots of space for this. Notice in this problem we have x's and y's. You really want to group together the x's, go together, okay, and then later the y's will go together. Okay, so I'm going to regroup this. Also, this positive 21, that's not going to be the right number, so that definitely has to get out of the way. So I'm going to definitely subtract 21 from both sides right away. So here is what I'm going to have. Looking at the x's, I'm going to have x squared plus 8x. Alright, now leave a space because we're going to complete the square. We're going to do half of the middle squared, so you have to leave a gap here. Now I'm switching over to the y's, and I'll do those in purple. Okay, so here come my y's are here and here. So that's going to be y squared minus 6y. And again, leave a gap here to complete the square. Leave a space there. Okay, and then over there off to the side we have negative 21 because we moved that over. So we're going to complete the square just like we did on the black screen. It's just that we're going to do it twice. So completing the square for the x's, we do take the middle term, we'll do half of this and square it. So half of 8 is 4. Okay, and then 4 squared is 16. So I'm going to do plus 16. Now don't forget, you have to do that on both sides of the equation. Very, very, very important. It's got to be on both sides of the equation. Okay, now I'm going to do the same thing with the y's. I think I'll pick a different color this time. I'll do light blue. Again, to complete the square, I do half of the middle squared. So half of this is 3. And then 3 squared is 9. So I'm going to put a positive 9 here and here. It's got to be on both sides. Okay? Now remember, the benefit of doing that is when I factor this, it's going to factor as the same thing twice. So it makes it easy to factor. Because x squared is x times x, 16, 4 times 4. I noticed it's positive, so it'll be positive and positive. Okay, so that's going to wind up being x plus 4 squared because it's the same thing twice. Now with the y's. Okay, this is going to factor as the same thing twice. Y times y makes y squared. 3 times 3 makes 9. Notice the negative sign. It's going to be minus and minus. Okay, so that means we will have y minus 3 squared. Do you see it starting to look like standard form? Alright, like I showed you at the very, very beginning. It's beginning to look like this green equation with the parentheses in it. Alright, that's what we wanted. Meanwhile, on the right hand side we have negative 21 plus 16 plus 9. Alright, if you add all that together, you get 4. Okay, so look at this equation very carefully. This is the standard form equation of the circle. Remember, we can get two things from this. We can get the center and we can get the radius. Okay, they only asked us for the radius, but this is good practice. I feel like switching colors. The center is going to come from this number and this number, but it'll be the opposite of what you see here. So the center will be negative 4 comma positive 3. Now the radius is going to come from right here. Remember, this is the radius squared. Okay, So if the radius squared is 4, then what must the radius have been? Alright, now technically you could just take the square root of both sides to answer that question and find that the radius is 2. Okay, so that should be the actual answer to the question, what's the radius? It is 2. Okay, so that's how you have to do that. So if they give you general form with no parentheses, you need to convert it to standard form by completing the square twice. Then you can find the center or the radius. Okay, let's do some more examples. I'm going to do them much faster now that you've seen it slow once. Alright, I'm doing just the odds, so that's why I'm going from 1 to 3. Anyway, same type of situation. We're given general form and we're being asked for the center. To find that, we need to convert this from general form to standard form by completing the square. So again, what I'm going to do is I will subtract this 11, get that out of the way. Now the x's, I'm going to regroup those so they're next to each other, and the y's, I'm going to regroup the y's so they're next to each other. So first of all, the x's. So I've got x squared plus 4x, so I write them side by side. X squared plus 4x, leave a space. And now the y's, y squared minus 8y. So I'll put plus y squared minus 8y, leave a space. And that equals negative 11 because I moved that over. Now it's time to complete the square. Half the middle squared. Half of 4 is 2. 2 squared is 4. So that's why I'm going to put a 4 on the left and the right. Keep the balance. I'm going to do the same thing with the y's. Half of 8 is 4. 4 squared is 16. So I'll put 16 on the left and the right. Okay, now it's time to factor and such. So when I factor this, it's going to factor as the same thing twice. So that's going to be x plus 2 times x plus 2. When I factor the y's, that's going to factor as the same thing twice. Y minus 4 times y minus 4. Alright, I knew it would be minus because of the minus here. 16 is 4 times 4, so these are really easy to factor. And then we have the this part over here. If you add all this up, that's going to be okay. Now, because of course these are the same thing twice, then I will have x plus 2 squared, and then I will have y minus 4 squared, and all of that equals 9. Okay, so now I can know the center and I can know the radius. Alright, the center is going to come from here and here, so the center will be negative 2, comma, positive 4. It's the opposite of each one of these. And the radius will be the square root of that, okay, because that is r squared. R squared is 9. If you take the square root, then r is 3. So the radius is 3. Okay, for this particular problem, they just asked us for the center, and here it is, negative 2, 4. Let's see how we did. Boom! We're on fire. Alright, this one's going to go really fast, which explains how to find the radius of the circle whose equation in this form. Well, the radius. So this is obviously a circle that is centered at the origin. all right, because it's just x squared and y squared. So remember, compare this to the equation that we spoke of at the beginning. X squared plus y squared is equal to the radius squared. So these are the same. So look what we have here. Z is in the same position as the radius squared. So in other words, the radius squared must equal z. So how would I find the radius? Well, I would take the square root of both sides, wouldn't I? Okay, I would take the square root of both sides, and so that means the radius should equal the square root of z. Alright, so we're looking for something that says something about that. The radius is the square root of the constant term z. Boom. That's it. Okay, this is problem number 7, by the way. Which equation represents a circle with the same radius as the circle shown, but with the center at -1, 1? Well, let's start with the center, okay, because we know that the standard form equation of a circle goes like this: x minus h squared plus y minus k squared is equal to the radius squared. And we know that the h and the k are the center, and those minuses tell us to do basically the opposite of what we see here. So far that gives us x, okay, and that -1 is going to become +1. This +1 is going to become a -1. You just do the opposite. Okay, all that's left is radius squared. Well, they said it should have the same radius as this. Okay, so this is 1, 2, 3, 4. That's a radius 4. Alright, 4, well, if the radius is 4, then the radius squared should be 16. Okay, and that's what we need in this position right here, is the radius squared. So we will put 16. So that is the equation of the circle that they just described, and that's what you see right here. Easy peasy, lemon squeezy. Alright, which equation represents a circle that contains this point and has a center at 4, 0? Okay, so the center is 4, 0. That's fine. And then we have some other point somewhere on the circle. Alright, now this doesn't have to be perfect in any way, shape, or form, but the idea is we have this other point floating around on the circle, and that's the point -2, 8. So we have these two things. And we're supposed to come up with an equation. Well, the center immediately gives us most of the equation, because we're going to go x minus 4, alright, by doing the opposite of the 4. And then we're going to go y minus 0 squared. And that's going to equal the radius squared, which is what goes right here. We'll erase that 0 on the next step. So we just need to figure out what the radius is. Now, the radius is the distance between these 2 points. Okay, so if I want to find the radius, I will use the distance formula. They were kind enough to give us the distance formula in case we forgot. But that radius should be the distance between these 2 points, which would be calculated by doing x minus x squared. Alright, so that will be -2 minus 4, or I could do 4 minus negative. The order really doesn't matter. So I'm just going to do -2 minus 4 squared. Now I'm going to do y minus y, so that's 8 minus 0 squared. And that should give me the radius. Now you should be able to do all this by hand. But if you have any trouble with that, I encourage you to use a calculator, because we got things to do. So that would look like this: square root of -2 minus 4 close parentheses squared plus open parentheses 8 minus 0. I really feel silly writing 8 minus 0. We know that's 8, but I don't want to confuse anybody. Boom. 10. Okay, that's giving us that the radius is 10. Okay, now be careful. So the radius is 10, but what we want is the radius squared. So if the radius is 10, the radius squared should be 100. You know, because here I've squared both sides. 10 squared is 100. Okay, so be careful. Don't put 10 here. Put 100. Okay. So your final answer should look like this. X minus 4 squared plus y squared, got rid of the unnecessary 0, is equal to 100. All right, let's see how we did. Okay, boom. Okay, which equation represents a circle with center -3, -5, and radius of 6? This again is ridiculously easy. We'll just do x plus 3 squared. All right, we did the opposite sign right there. And then we'll do y plus 5 squared. Okay, just did the opposite of that. And then next comes the radius squared. Well, if the radius is 6, then right here I'll put 36. So that should be the end of that. Boom. Okay, which equations are circles that have a diameter of 12 and a center that lies on the y-axis? Well, diameter of 12 tells us that the radius is 6. Okay, and then that means that the radius squared will equal 36. All right, so based on that alone, we're only looking at equations that have 36 at the end. So we can forget about this one and we can forget about that one. Okay, now the other piece of information is that it lies on the y-axis. So if you have any point on the y-axis, you know, let me put a couple marks on here. Okay, so here come 5 points on the y-axis. Boom, 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 boom. They all have something in common. This one is 0, 2. This one is 0, 1, 0, 0, 0, -1, 0, -2. What do they all have in common? The x value is 0. So if you're on the y-axis, you know that it's going to be 0, something. All right, it's going to be 0, something, but it has to be 0. All right, so if the center is on the y-axis, okay, when we talk about the center, we normally use the letters H and K to represent the center. But if it's on the y-axis, we know that the H part is going to be 0. So it'll be like 0, something. So when we go to write our equation of the circle, we would go like x minus 0 squared, and then we'd have our y minus k squared. And we already know the radius squared is 36. So this would be x squared, all right, because we don't need the 0. And then y minus something equals 36. That's an equal sign. So we're looking for the equations that fit this form. Basically, k can be whatever. K could be anything, but it should just be x squared. So looking at this one, I see x squared, so that one's good. I'm liking this one. This one is x minus 4. That's no good. All right, should just be x squared. This one has just x squared again, so that's good. All right, this k, it could be positive or negative, it doesn't matter. So these two are good. Okay, and that matches up. All right, this will be the last one that I'm going to do. does this point lie on the circle? Explain. Okay, well, we know the radius of the circle is 3. You know, looking at one of the horizontal or vertical pieces, we know that the radius is 3. Okay, so the distance between the center and any point on the circle should be 3. Okay, if there's a point right here, okay, that should have a distance of 3. If there's a point over here, that should have a distance of 3. The radius is 3 in all directions. So wherever this point is, 2 comma radical 6, let's estimate it just for fun. Okay, the square root of 6. Okay, that's it's a 2.4. It's almost 2.5. Okay, so we're talking about a point that's like over 2 and up 2.5. Okay, so over 2 and up 2.5 would be like right about here. So that's pretty close. And you know, maybe the drawing's not quite to scale. But at any rate, if I want to see for sure whether or not that point is on the circle, I don't know why it keeps disappearing on me, but I need to look at the distance between the center and that point. And because that distance should be 3 because of the radius. If that distance is not 3, then I know that point is not on the circle. So let's do the distance formula. Okay, so the distance between those 2 points should be the square root, and we do x minus x. So I'm going to do 2 minus 0. I'm doing x minus x squared. Now I'm going to do y minus y. So I'm going to do the square root of 6 minus 0 squared. And let's see what we get. Now I really don't need to put the zeros into the calculator. So please understand that right away I'm going to have this. I'm going to have 2 squared plus the square root of 6 squared. Alright, that's what it is without the zeros. Okay, now before I touch a calculator, still, come on, 2 squared is 4. Now this is something that you should get comfortable with. If you take a square root and you square it, the square root and the square cancel each other out. So I'm just going to have 6. Okay, 4 plus 6 is 10, so that's the square root of 10. Alright, the square root of 10 is not 3. Okay, it does not equal 3. I mean, you know, what is it? It's some decimal. We can check it out if you want. If you insist, I hear you nagging me to do it. It's 3.16 something. Okay, that is not equal to 3, which we know it should have been if it was on the circle. So therefore, it is not on the circle. Okay? Now remember, if you had any trouble, I mean, I went ahead and did this one by hand and got the radical 10. If I lost you in there at any point, you could have just put the original problem in your calculator if you really have weak skills. No offense. If you look back at this, no, the distance from 0, 0 to 2 radical 6 is not 3 units. So they're concurring with what we just said. Okay, I hope this video was helpful, and I hope you will be successful as you try for the quiz.